In this video, we'll cover Citrix SD-WAN's functionality of link aggregation, network resiliency, and Standby WAN link demonstration. Before we begin the demonstration, I would like to first bring your attention to the network topology used for this demo, which highlights simply a branch office site accessing apps and data from a data center site. For the branch office site, we have three distinct WAN links: a fractional T1 at 500 kilobits per second, a 2 meg up and down internet link, and a 1 meg up and down LTE link purposely configured to be in standby mode. Next, we will show the SD-WAN device's local web interface, where each one of these WAN links are monitored individually for best one-way time, jitter, loss, usage, and congestion. Notice that the Citrix SD-WAN solution monitors the links unidirectionally, meaning the upload and download of each WAN link branch to DC is monitored separately from DC down to branch, allowing for the Citrix SD-WAN overlay network to utilize all available bandwidth intelligently in application delivery between these two sites. We will now enable auto refresh on this page so that we can see the real-time stats of each unidirectional path on a 5-second refresh interval. With the network understood, we will now log into a host machine at one of the sites and initiate JPerf traffic to provide a visual gauge of the detected bandwidth between the two sites. In the SD-WAN monitoring, we can see in real time how the single application is being load balanced across multiple WAN links simultaneously, roughly 400 kilobits per second across the fractional T1 MPLS, and roughly 1.8 megabits per second across the internet link. We will now purposely bring down the internet WAN path, leveraging only the MPLS path available between the sites. Again, note that the LTE link is configured as a standby WAN link. You should immediately notice the JPerf graph dropped from 2 megabits per second down to 400 kilobits per second. And on the SD-WAN web interface, you will notice the related internet WAN link properly being monitored and reported as unavailable for path state. This demonstrates the differentiator of the Citrix SD-WAN solution, reacting to WAN link condition changes at a sub-second level, allowing for the session, in this case JPerf, to continue to operate with no disruption to the connection or the end-user experience. The only impact is the loss of aggregated bandwidth. Next, we will showcase the standby WAN link functionality of the solution. We will purposely bring down the remaining non-standby WAN link, the MPLS link. The JPerf graph results in a momentary outage as the SD-WAN makes use of the standby WAN link. The throughput results in about 1 megabits per second, the bandwidth configured for the LTE link in this demo environment. In this configuration, the standby WAN link is only used in the most severe outage conditions, where all non-standby WAN links are completely unavailable. This feature can significantly save on WAN cost on those expensive link types like LTE, providing additional network resiliency, but making it manageable. We will now restore the health of the MPLS link and showcase how the SD-WAN will put the LTE link back into a standby state with availability of the first non-standby WAN link. You will notice that the SD-WAN will seamlessly transition off the LTE and onto the MPLS path, but first put the path into a yellow state before committing any traffic to it. The JPerf graph will visually demonstrate how the SD-WAN immediately stops using the costly 4G LTE link and goes back to start using the non-standby paths that are available, roughly 500 kilobits per second of available bandwidth between sites. Now we will restore the health of the internet link and showcase how SD-WAN will make full usage of all non-standby WAN links with aggregated bandwidth. Again, you'll notice that the Citrix SD-WAN will transition the internet path to a yellow analysis state before bringing it back into a good usable state. But as soon as it does and trusts the link to commit traffic, the JPerf graph will visually demonstrate how SD-WAN immediately makes the aggregated bandwidth available for the iPerf application. Usage of aggregated bandwidth is another differentiator of the Citrix SD-WAN solution, delivering a single session across multiple distinct WAN links, effectively utilizing all available bandwidth to send more data across the virtualized wide area network. The result of this is much improved end user experience with richer content being delivered. This concludes the demonstration of Citrix SD-WAN link aggregation, resiliency, and standby WAN link.